Alright, welcome back everybody. Haven't been able to do much on the Avanti this weekend. Had a relative in town for the weekend, plus I'm waiting on still waiting on my servo arms to come in from DreamWorks. It being Veterans Day, the mill is probably not going to run today, so probably tomorrow, and then I go back to work tomorrow. So shout out to all the fellow service members, past, present, and future, for Veterans Day. Hope you have a good one. So this video is to kind of show you a couple things real quick, just for the heck of it. I was going to do it anyways, just for informational purposes, but I decided to go ahead and do it since I didn't have anything else to do. So anyways, I decided I'm a big fan of the high flow stuff when it comes to turbines, even the smaller turbines. You know, if you eliminate any restrictions and give it, you know, the most, you know, the largest diameter that you can get, it just helps your pump, you know, reduces the pressures on your pumps, and, you know, just helps your fuel system altogether, I think. So I've been a fan of these MAP high flow UATs, and I decided to give BBM's high flow stuff a shot, because I'm always looking for, you know, things like clunks and the biggest diameter I can get, and Tygon tubing that I can get. So they came out with their new high flow products, and I went ahead and ordered some of the high flow fuel clunk or fuel tank clunk line, and some other high flow tubing. The high flow tubing is pretty much the same as the clunk line, and the problem with it is, though, they only sell it in like 1 foot sections. They do sell a Tygon tubing, which is perfect for this, in like 8 foot sections, which is what I ended up getting to, so it worked out. But for any of you guys who have used their clunks in the past, this is the old standard clunk. This is the new one. You can kind of see the differences there. This is what's supplied with the jet itself. Weight wise, a little bit heavier. The ones from Skymaster, but the diameter is, or inner diameter is crazy small. I wasn't going to use these regardless. I usually take and drill them out, but this one's just such a small hole I couldn't drill it out to anything useful. So I just decided to go with these. Yeah, this is only like a 3mm, not even a 3mm hole on the inner diameter. The BBMs are roughly almost 5mm, so quite a bit larger inner diameter. And what I thought was interesting is the MAP high flow tanks, the inner diameter of that, let's see, is just a little bit smaller than the BVM. Pickup line, yeah, 4.7mm for the high flow UAT, and 4.7, yeah, they're the same. So that works out good. And these are fairly cheap. These aren't expensive, you know, they're like $8 or $9 for them, so I'm happy with that. I am going to use a very large brass tubing. This is actually larger than the high flow stuff. It's 5.7, 5.6mm inner diameter. If I could get something a little bit smaller, I would, but this is as small as I can get without going down to the next size. So this is going to be the brass tubing I use for the vents and the clunk line going through the rubber stoppers. This is the stocker from stopper, not stocker. stopper from BBM. These are some I had from an old Fly Eagle. These are really good stuff. They're real rubbery and soft, which makes for really good seals. And I'm going with this one because I'm going to be using this larger piece, and I'm only going to have one line going through. So the problem I got to come up with is the stock hardware, the metal hardware, you know, the front plate and the back plate that pinch on the stopper are smaller diameter, and it's kind of hard metal, and it's almost impossible to drill with what I have. So I may you know, find somebody with a good drill press and drill them out. I'm going to use some old back plates that I have with a threaded insert for the screw. They just got to be, I've just got to cut one hole larger to accommodate the brass tubing. So I'll do that when I can. I got the aileron servos done. You can kind of see them here. I'm using the supplied hardware for the servo arm. I normally don't use these. I normally put like the ball ends on both ends, but this seems to be where I'm gonna give it a try. See how it works. I got to do the control horn, but I'm gonna wait till I get the servo arms in so I can do the flaps. So I'll have the flap servos installed and the ailerons, and I'll just go ahead and cut them all at once and glue them in that way with high saw. Yeah, that's about it. What I'm going to try to do is a few little things today that I can until I get my servo arms and stuff back in, and then I'm going to go ahead and get all the servos in and stuff like that. So I don't know if I told you guys, but I'm using 9074s for ailerons, and the flap's going to be running 6 volts because they're just 6-volt servos. And for the elevators, I'm going to be running 172s, and the rudder 172s, which are 500 ounces of torque. And then the thrust vectoring is going to be running 175s, which are 300 and something for the thrust vectoring stuff. So I'll be running 7.4 volts to the tail and 6.4 to the wings, or 6.6 to the wings, because the Fatabi Robi battery backer they have allows, because it's got four slots, and you can have, you know, 2 going to the tail, 1 to each wing, or however you want to do it. But you've got Alpha 1, Alpha 2, Bravo 1, Bravo 2. What they do is allow you to change voltages between the pairs. So you can go Alpha, you can do 6.6, 6 volts, 7.4 volts, and then you have Bravo on a different voltage. And then these are all regulated, I believe, to, shoot, I have to look it up. It's either 6 volts or 4.8 that go out to your receivers and stuff like that, and all the little things that I'll plug in here. I'll plug the nose servo in, which is going to be a one of these 9074s, the nose steering, and then any kind of, I'm going to be using small high-tech servos to operate the air valves. They'll all be plugged into here as well, so they'll be regulated voltage down to the 6 volts. But that's that as well. I was talking to a couple guys on the forum about the thrust vectoring. It's very unclear for a lot of people. Apparently people have some different hardware, different pipes, different size thrust pipes and stuff like that. And this is what they gave me, this back ply plate, the bulkhead that this mounts to, and I'm guessing that the tailpipe goes to this as well. I noticed on some of the other pictures from their website of other models that they were getting ready to ship, this was already installed. I don't know if they just missed it on mine or if it comes, you know, like this for all models now. I don't know, but I'm going to have to glue it in, but there's really no instructions on it, on where it goes and stuff like that. So hopefully SkyMaster will come up with a more detailed description of that and how this front plate goes. I mean, it's pretty simple. I mean, it's going to go obviously centered on your turbine, but how does the turbine mount to this? Some pictures I've seen are L brackets going to the, you know, where the bell mouth bolts in, but I don't have any more L brackets, so either they didn't give me hardware or it's not right. So that's about it. Like I said, can't do much right now because I'm waiting on the servo arms. So I'm going to go ahead and get all the servos installed and just be waiting on the servo arms. And I may go ahead and work on getting the tanks plumbed as well, because I gotta cut the hole bigger for the larger clunk, and then just like I did with the F-15, I'm going to take some small square aluminum, real thin aluminum sheeting and glue on, cut a hole in it the size of the tank hole, glue it on with high sol to give this something to sit on and expand and put pressure on instead of just the actual carbon or the Kevlar itself. Because if you put a clunk straight to this, as it expands when you tighten that bolt down for the clunk, it expands, puts pressure against the outer wall or the inner wall of that hole, and it just starts getting those little spider cracks, little spider vein cracks. So what I did, not as bad on these tanks, but it does it on these too, but if you have the fiberglass tanks, it's really bad. So I'm going to glue the aluminum plate on here around the hole with a hole cut in it, put the clunk in, tighten it down that way, so when it expands, it's got that aluminum support there to keep it from cracking. But yep, that's it. I'm going to get back to putting in servos installed. I'm going to use the rubber. I know a lot of guys don't put the rubber on their servos with the bushings, but I'm going to use them on this one. I know you don't have vibrations like you do the big planes and stuff, but I think the only ones that I did the regular, you know, the jet style, I guess you could call it, without the rubber stoppers, was the ailerons. I think for everything else, I'm going to put the rubber bushings and stuff in there. So, anyways, just me talking, not much building wise to show you guys. So I'm going to get back to it. I'm going to like I said, get the servos installed for each control surface, and that'll probably be about it today. Really not much I can do. Maybe go ahead and cut the aluminum plates for the fuel tanks, and then glue those on, let them be setting up, things like that. And yeah, that's it. You guys have a good one. And like I said, all the veterans out there, enjoy your day off. And I'll talk to you guys later. Hopefully I can get some more stuff done tomorrow when my stuff comes in. But like I said, I'm going back to work tomorrow, so I won't have all the free time like I have right now to work. So you guys take it easy.